Okay, here's a video on lesson 71, exponential and logarithmic inverses. Let's cover the notes first, and then I'll give two examples, and then you should be good to go. What is an inverse? An inverse is a function that undoes another. So what that means in technical terms is that if we had two functions, right? If we had f of x and g of x, alright, f of x and g of x, two different functions. If I compose them, f of g of x, right, that would become just x, if these two were indeed inverses. Meaning, if I took, for say, the number 2, and I plug the 2 into the g function, and I evaluate it, and then I plug that number into the f function, the number that I get out of that would be 2. What does it look like on a graph? Well, inverses look like a reflection over the diagonal lines x. The way that we find an inverse of any function is, well, as soon as it says inverse, we know we have to switch x and y. And then in order to make it look like a function, we need to solve for y equals. Now I'll give you an example of this. We did some examples in lesson 70 where we switched x and y and we solved for y on some real simple functions. But on lesson 71, our focus is going to be on logarithmic and exponential functions. So let me give you both 4 and 5 are examples. How do I find the inverse of a logarithmic function? And for example, y equals log base 2 of x minus 7. Now let me go to my notes. The way I'm going to do this, finding the inverse of this logarithmic function, is first I'm going to switch x and y. So this becomes x is equal to log base 2 of y minus 7. Once I've switched x and y, my goal is going to be to isolate the logarithm if needed. Well, let's see. The logarithm is this. Does it need to be isolated? Yeah, this needs to go away. So we got to get rid of this. In order to get rid of this, I'm going to plus 7, so this cancels out. And I need to plus 7 on the other side as well. So this is by itself now, which is great. So this is x plus 7 is equal to the log of 2y. Alright, the log is now isolated. Good, done with that. Now I like my logs on the left, so I'm going to rearrange this, right? I'm going to put the log first, just rearrange it around the equal sign. So I've got the log base 2 of y is equal to x plus 7. And now I'd like to get the y by itself here. So what I'm going to do is I'm going to use the swoop. 2 to the x plus 7 equals y. And that's how the swoop works. 2 to the x plus 7 equals y. And look at that. Y equals, it's all by itself. That is indeed a function. As soon as it says y equals something, I know I'm done. Now, to find the inverse of an exponential, it's going to be a little bit different. So if what you're looking at is the inverse of a logarithm, right, you want to refer to this for, right, inverse of a log, this is the general steps right here. The general steps for an inverse of an exponential are going to be, like I said, slightly different. So what we want to do is, it says inverse. So if it says inverse, we're always going to be doing switch x and y. Right? If we didn't do that, it's not the inverse. So let's switch x and y first. I'm going to get x is equal to negative 4 to the y over 3. Now I need to isolate the exponential term. So let me see what the exponent is even on. The exponent is only on the 4. So to isolate it, to get it by itself, I'm going to need to get rid of the divided by 3 and the negative sign. So what I want to do is, to get rid of divided by 3, I'm going to times 3. But I want to get rid of the negative, so it would be great if instead I did times negative 3, because what a negative and negative become but positive. Right, so these will really cancel each other out, the negatives, and the 3's divided by 3 times 3, those will cancel each other out too. If I want to do this on the right, I have to also do it on the left, so times negative 3. These will cancel. Negative 3 times x, that's negative 3x, is equal to 4 to the y. Now the y is almost by itself, but remember, I'm going to need to bring it down. So here's how I do that. I am going to first give myself a little room. Negative 3x is equal to 4 to the y. In order to bring something down, I need to log. If I log one side, I need to also log the other. And now I'm allowed to bring the y down, and it becomes a coefficient on the front. It's no longer in the exponent spot. So what I've gotten here is I've gotten the log of, almost forgot my negative sign, of negative 3x is equal to y times log of 4. Now, I got to divide off the log that's attached to the y, because we want y equals. I don't quite have it yet. So I'm going to divide by log 4. These will cancel. And now I've got y equals this. Let me rewrite that. Y equals log of negative 3x over log of 4. And my last step to clean this up, I am going to do what we call pancake. Right? I'm going to smush this together. When I smush it together, it becomes a single log. So I've got y equals a single logarithm. The 4 is on bottom, so it stays low, smushed down here into the base, and this is negative 3x. And so this stays as the base, and the negative 3x stays in line with the log. It's now the argument, the thing that the log is being applied to. Y equals log base 4 of negative 3x. And the way we pronounce that, by the way, is log base 4 of negative 3x. Okay, so if you have to solve a question that is the inverse of an exponential, this is the general idea of how to do so. Right? These steps, we're going to switch x and y, isolate the exponential term if needed. We're going to log and bring down, divide off the log on the y, and then pancake it to clean it up at the end. Alright, so if you have any examples that start off as an exponential and you need to find the inverse, these are the general steps and how you would do it. If you need any advice on that, please feel free to rewatch examples 4 or 5. Good luck, see you in class.